Welcome, Solutioneers. I am Marcel Howard, the Policy Analytic Coordinator here at Upstream. Thanks for joining us. Welcome to the Climate, Plastics, and Reuse Training Program. This training is designed to provide valuable insights into the connections between climate, plastics, and reuse. In addition, this recording shall be used as a guide for those that would like to provide their own presentation to any key stakeholders they are engaging with on these topics. We very much hope this information will be useful to you and that we can all continue to educate and engage others to join the reuse movement and become a better solutioneer just like you and I. Welcome to the Climate, Plastics, and Reuse Training. Here we focus on how to incorporate climate change related impacts into work on reuse policies, as well as how to weave reuse into work on climate action plans. I'll start by discussing the key challenges that have led us to the current climate state that we're currently experiencing before covering consumption-based emissions inventories, or CBEIs, climate action plans, also known as CAPs, and key life cycle analysis data that supports reuse as a climate mitigation strategy. So although we want to stay focused on the solutions, it's very important to understand the key challenges facing the world regarding plastics and climate change. First, global carbon emissions have significantly increased by about 90% since 1970 and are continuing to increase. Second, a population of nearly 8 billion and growing is embracing a throwaway economy centered around single-use products, which is not sustainable. This throwaway economy has caused there to be over 150 million metric tons of plastic in our oceans. And lastly, these issues are only being exacerbated by the further expansion of the plastics industry, specifically fueling a petrochemical infrastructure build-out, which disproportionately affects Black and Brown, low-income, and Indigenous communities. These are just a few of the key challenges that the throwaway economy has created, and these challenges are vastly contributing to the climate and plastics problem the world is facing today. The world's population is nearly 8 billion people and expected to grow by an additional 2 billion in the next 30 years. Resource use, waste production, and environmental degradation are accelerated by population growth. This is further exacerbated by an economic model that embraces and rewards the production and consumption of single-use disposable products and packaging, also known as the one-way throwaway economic model. So while single-use packaging is used for all kinds of consumer products, we focus on transitioning food and beverage packaging to reusables as the top priority for a variety of reasons. The first is that the data shows that food and beverage packaging escapes the waste management system and escapes into the environment more than any other product type. While as an individual item, cigarette butts have always topped the charts of Coastal Cleanup Day data, looking more closely, we see that grouped together, about 75% of the top 10 littered items are food and beverage packaging. Meanwhile, other litter studies show that about 70% of the products that are littered on city streets, which was through storm drains and out nearby creeks, rivers, beaches, and coastal waterways, is comprised of single-use food and beverage packaging. So what do we mean when we talk about our current one-way throwaway economy? The one-way throwaway economic model in the food service industry starts with the extraction and production phases of single-use foodware and packaging, which has significant climate and energy impacts. The food service industry uses nearly 1 trillion pieces of disposable foodware a year and spends $24 billion on these items that consumers will use in a matter of minutes or not at all. This then generates 9 million tons of waste, which is equal to that of 25 Empire State Buildings, and over $6 billion in waste management costs. And a lot of it never makes it to the actual waste stream or system. Upstream's calculation is that these products account for 20 billion pieces of litter, and local businesses and cities spend approximately 11.5 billion on litter cleanup a year. Now, most individuals look to make try to make these things more compostable or recyclable. But the reality is, recycling and composting aren't always great solutions for food packaging. There's a lot of mythology around the potential of these solutions. We know that most recovered materials are downcycled or end up in landfill or incineration, like foodware, because they are too contaminated to be recycled into new products. Plus, only 5% of all plastic waste ever created has been recycled, majority of which is only soda and water bottles. In addition, compostable products are also a bit of a myth. For compost, plastics, even certified compostable plastics, contaminate compost, which lowers the overall quality of compost, making most commercial composters not want the product in the first place. Plastic compostable products are often selected out of the compost piles and are sent to landfill, where it has 30 times more greenhouse gas impact than packaging that is composted. So recycling and composting are solutions for certain materials, but they are not the best overall solution to plastic pollution and the ever-increasing single-use packaging waste stream. Now, when we think about the single-use throwaway culture, what we need to do to change it, most people immediately think about banning plastics in general. There is over 150 million metric tons of plastic in our oceans as of 2015, and the problem is growing. However, the question I'd like you to think about is whether banning single-use plastic is the right solution. The answer is yes. Banning single-use will help solve the plastic pollution problems, but the consequences of only focusing on one material type is that the alternative single-use materials have a host of environmental and human health impacts that mean we're really just shifting impacts. The alternative single-use materials can be just as devastating and sometimes worse. Other single-use materials cause pollution, exacerbate climate change, extract precious and limited natural resources, propel loss of biodiversity, and threaten human health. In these ways, they are regrettable substitutes. And these regrettable substitutes demonstrate that the problem isn't just plastic, it's single-use itself. Bio-based plastic, for example, are made from plants like corn or starchy crops. These require fossil fuels to grow, and in industrial agricultural growing systems means loads of fertilizers that pollute ground and surface water. Think big dead zones in our inland and coastal waterways as a result of contaminated agricultural runoff. Many people think that single-use aluminum is the answer because it's highly recyclable. And while aluminum cans may contain an average of 73% recycled content, the non-recycled or virgin aluminum portion is very harmful from a carbon emissions lens. It has 5 times more carbon impact than the recycled content. And the mining of virgin aluminum releases perfluorocarbons that are 9,200 times more harmful than CO2 emissions. That's staggering. And the age-old question of paper versus plastic, the answer is neither. Half of all paper produced each year is for packaging, and that results in cutting down 3 billion trees a year. Trees are our precious defense against carbon emissions, as they act as a carbon sink, consuming CO2, and also provide cooling for a warming planet, plus clean air, habitat for diverse wildlife, and clean water. The disposal of paper can also result in greater GHG emissions compared to plastic. And lastly, wood used as a single-use product, such as bamboo, can also have devastating environmental impacts, as these plants are grown in monocultural agricultural systems that result in loss of biodiversity, heavy soil erosion, and runoff polluted by fertilizers and sediments. Now, when we shift our approach away from single-use itself and prioritize reuse solutions, we can create a new and sustainable economy for food service. By just shifting on-site dining 100% to reusable, and building out a new infrastructure in cities where at least 82% of the US population resides, then we could do the following. Remove 86% of disposables from the system, equating to 840 million pieces of packaging. We could save businesses $5 billion, save communities $5 billion in waste management costs, eliminate 17 billion pieces of litter, and create lots of local jobs in our communities in this beautiful new reuse economy. So reuse is not only great for the environment, but it's also great for businesses and cities alike. Now, it's important to note that products and packaging comprise of 37% of US consumption-based emissions and 44% of global consumption-based emissions. It is by far the largest contributor to overall US consumption-based emissions. This has substantially contributed to climate change, but has left the door open for reuse as a climate mitigation strategy. But with the promise of this new economic model centered around reuse, one may ask, how do we achieve this? Well, the first step is in understanding CBEIs, or consumption-based emissions inventories, and the importance of making them the new status quo for cities and municipalities looking to account for the full breadth of greenhouse gas emissions being emitted by their residents. Historically, sector-based emissions inventories have been the status quo for calculating a jurisdiction's total greenhouse gas footprint. Sector-based inventories capture emissions from the household use of fuel and electricity, consumption of goods and services produced in the city, and greenhouse gas emissions from exported goods and services. However, Sector-based inventories do not capture the greenhouse gas emissions produced from imported goods and services. This is where CBIs are useful, as they calculate the emissions associated with producing, transporting, using, and disposing of products and services that are imported to a particular jurisdiction. For example, in Oregon, more than half of the consumption-based emissions occur in other states or nations that are not included in the sector-based inventory. Together, these two inventories tell a more complete story of how a jurisdiction contributes to climate change and, by extension, opportunities to reduce emissions. Local and state government should be using both forms of accounting of greenhouse gas emissions to accurately account for their total climate impacts. Now, another way to think about sector-based emissions inventories versus consumption-based is looking at it from a global approach versus a snow globe approach. A CBI offers different categories or buckets of emissions than the traditional sector-based emissions inventory. For example, the life cycle emissions from the turkey that went to New York from Minnesota are not counted in a CBI, but the life cycle emissions from a coat made in China and bought in Minnesota are. CBIs cover the emissions from anywhere in service of things consumed in Minnesota, while sector-based account for only the emissions produced in Minnesota, regardless of where things are consumed. So, for products and packaging, those that are imported into the jurisdiction, as many products are, the consumption-related emissions of those products are not accounted for when using only the sector-based emissions approach. CBIs are extremely valuable, as shown by C40, who did a CBI analysis of 79 of the C40 cities. C40 is a network of mayors of nearly 100 world-leading cities collaborating to deliver the urgent action needed right now to confront the climate crisis. C40's mission is to halve the emissions of its member cities within a decade, while improving equity, building resilience, and creating conditions for everyone, everywhere to thrive. The study examined the GHG emissions associated with goods and services imported into the cities, and they found that greenhouse gas emissions generated by the world's greatest cities are as much as 60% higher than currently estimated. They also found that almost 2/3 of these consumption-based emissions are generated in the supply chains of goods and services imported from regions outside of cities. Lastly, 15 cities, mostly in Europe and North America, have consumption-based emissions at least 3 times the size of their emissions calculated using the standard sector-based emissions inventory. Now, it's important to understand the limitations of CBIs, as these distinctions can be very important when considering and prioritizing policy interventions. First, CBIs lump consumption into categories. For example, CBIs don't show that meat production has larger emissions footprint than other types of food, but instead is lumped into one single category. 2, such categorization treats all residents' consumption as equal, which we know not to be true because consumption levels tend to vary widely within cities, and research shows high-income households typically have a larger consumption footprint. And 3, emissions can occur at different life cycle phases and is not depicted through a CBI alone. For food, most emissions are associated with production, and for appliances, the majority of emissions result from use. So again, these distinctions can be very important when considering and prioritizing policy interventions and showcase the reasons for developing CBIs in conjunction with sector-based emissions inventories. Now, we see consumption-based emissions inventories as an important tool for capturing the full story of greenhouse gas emissions for a jurisdiction. With the expectation that CBIs will uncover higher greenhouse gas footprints, there will be a need to reevaluate current climate mitigation strategies and climate action plans in order to address the new emissions found and to reprioritize planned actions based on the largest sources of emissions. With more than 600 local governments across the US having adopted their own climate action plans, or CAPs, CAPs present an opportunity for the integration of source reduction and reuse solutions to be embedded as a climate mitigation strategy. Now, climate action plans around the country are becoming increasingly more robust and encompassing topics that may not have had a key focus area a few decades ago, such as consumption reduction. In order to get a better understanding of how CAPs are incorporating consumption reduction concepts, Upstream analyzed 52 CAPs from across the country. You can tell by this map the breadth or the scope of climate action plans that we analyzed, and this includes 14 of the 17 North American C40 cities, which are highlighted in green. The CAP analysis shows the opportunity that exists within CAPs for embedding consumption reduction and reuse concepts. Currently, only 19 of the 52 climate action plans analyzed included language around both consumption reduction and reuse. Although further analysis is needed, one can assume this trend would continue when reviewing additional CAPs from across the country. The missing language presents a strong opportunity to introduce consumption reduction and reuse concepts as a low-hanging fruit mitigation strategy, which would help cities and municipalities reduce the additional greenhouse gas emissions that would be uncovered through the use of consumption-based emissions inventory. Some cities that included language for consumption reduction include Boston, Minneapolis, Pittsburgh, and Victoria, British Columbia. And for reuse and refill language, we have Chicago, Jersey City, New Orleans, and St. Louis, just to name a few. Now, the CAP strategies vary widely among plans, but a few cities have proposed model language that should be highlighted. First, the city and county of LA adopted specific reuse targets to help them achieve their CAP goals. One, increase the proportion of waste products and recyclables productively reused and or repurposed within LA County to at least 25% by 2025 and 50% by 2035. And two, to reduce municipal solid waste generation per capita by at least 15% by 2030, including phasing out single-use plastics by 2028. Secondly, the city of Philadelphia updated their CAP in 2021 to prioritize reuse pilot and educational programs to engage residents, businesses, and institutions in reducing consumption and expanding circular materials management systems. And lastly, San Francisco made a commitment that by 2030, through a combination of policy, education, outreach, and new infrastructure solutions, it would cut its generation of discards by 15%. Now, in addition to understanding the language gaps and opportunities that exist within climate action plans, there are major data gaps that have failed to show the emissions impacts of disposable food and beverage packaging. After reviewing various LCAs focused on the emissions impacts of single-use disposable foodware, Upstream found that reusable food serviceware beats single-use alternatives through every environmental measure, from climate, water, land use, to waste, to pollution impacts. This is mainly due to the fact that reusables have always hit a break-even point where they outperform the disposables and the benefits to the environment accrue with each additional use past that point. Now, let's take a deeper look at what the data has to say about reuse. Based on LCA data collected in the Reuse Wins report, we provide this comparison of the CO2 impacts of various disposable and reusable plates and clamshells. As you can see, disposable clamshells and plates have substantially more CO2 impacts than their reusable counterparts. Specifically, bagasse clamshells, or those made from sugarcane, have the highest CO2, while polypropylene clamshells have the lowest, clearly showing that even single-use alternatives to plastic have very significant environmental impacts. Here, we have a list of CO2 impacts of various disposable and reusable cups. As you can see, we have a similar case as we did with the plates and clamshells, but paper cups shows the most CO2 impacts. For cups, it's clear that all three types of reusable cups have vastly less CO2 impacts than all of their disposable products. Again, showing how reusables beat disposables every time, especially when it comes to CO2 impacts. Reusables always hit a break-even point where they outperform the disposables and the benefits of the environment accrue with each additional use past that point. For cups, the break-even point is between 2 and 122 uses. For plates and clamshells, it's between 3 and 50 uses. And for utensils, only 2 uses of reusable is required. In addition, reusables can save on energy and water consumption. The use of efficient dishwashing equipment has the potential to reduce overall energy usage by 45% for a reusable system, and making 500 single-use paper cups requires 370 gallons of water, while making one ceramic cup and washing it 500 times requires only 53 gallons of water. So let's put this into practice. Howard City is a hypothetical city on the East Coast of the United States with a population of 800,000. As a tourist destination, Howard City has an expansive food service industry that relies heavily on single-use disposable foodware. The mayor of Howard City is interested in learning more about the greenhouse gas footprint of these disposable products have on the city. Now, for this scenario, we're assuming each person in Howard City uses 3 items per day per year. So each person using 1 plate, 1 clamshell, and 1 cup per day per year. Using a conservative estimate, we are assuming that on average, each person uses one PLA plate, one sugarcane clamshell, and one paper cup with PE liner and paper sleeve a day for 1 year. And this scenario would equate to about 131,400 metric tons of CO2 per year if everyone used these 3 items per day. Now, using a conservative estimate, we are assuming on average, each person uses one reusable plate made out of ceramic or porcelain, one reusable clamshell made out of polypropylene, and one glass cup a day for 1 year. In this scenario, this would equate to about 9,928 metric tons of CO2 per year if everyone used these 3 items per day. This equates to a savings of about 121,472 metric tons of CO2. This shows that even when using a conservative estimate, reusables bring substantial environmental benefits. Specifically, reusables produce a substantially lower amount of CO2 emissions than their disposable counterparts. Now, we've covered some of the key challenges the world is facing regarding climate and plastics, the importance of consumption-based emissions inventories, and the role climate action plans can play in uplifting consumption reduction and reuse, and the existing climate data that shows the vast benefits of reusables. However, what may be most important is understanding who is impacted the most by climate change and how reuse can help mitigate those disproportionate impacts moving forward. Environmental justice is the fair treatment and meaningful involvement of all people, regardless of race, color, national origin, or income, with respect to the development, implementation, and enforcement of environmental laws, regulations, and policies. This goal is achieved when everyone enjoys the same degree of protection from environmental health hazards and equal access to decision-making process to have a healthy environment in which to live, learn, and work. Now, there have been some key environmental impacts to communities that have been exacerbated by the plastics industry. First, the US plastics industry is quickly expanding, with at least 42 facilities open since 2019, under construction, or in the permitting process. These new plants will release an additional 55 million tons of greenhouse gases. The health impacts of these emissions are disproportionately borne on Indigenous communities, communities of color, and low-income communities. 2, plastic pollution is not shared equally in the US. 90% of the reported pollution from US plastics manufacturing is released into just 18 communities, located mostly in Louisiana and Texas. The people who live within 3 miles of these petrochemical clusters earn 28% less than the average US household and are 67% more likely to be people of color. And third, less than 5% of plastics are recycled, 11.8% of municipal solid waste is treated in waste incineration, a major source of both greenhouse gas emissions and harmful air pollutants. Waste incineration is usually located in environmental justice communities, exposing residents to toxic air emissions and leading to a disproportionate number of health issues like respiratory problems, birth defects, and cancer. Now, in order to combat some of these community impacts, reuse can be a potential pathway for a just transition. A just transition refers to building upon an economic and political power shift from an extractive economy to a regenerative economy, and approaches production and consumption cycles holistically and waste-free. The transition itself must be just and equitable, redressing past harms and creating new relationships of power. Now, how is reuse a mechanism for a just transition? Well, non-toxic reuse helps reduce overall pollution, toxic chemical exposure, and litter, and can greatly improve the overall living conditions of a community while reducing overall litter and waste management costs for local businesses and government alike. Reuse services create good local jobs. The logistics of reusables collection, washing, and redistribution provide safe local jobs, whereas disposable related jobs are in other locales where extraction, production, and disposal takes place. Reuse can also help turn off the tap for single-use plastics, as it reduces the demand for single-use products. It can reduce the need to expand production operations that disproportionately affect Black and Brown and Indigenous communities who are often living on the fence line of industry. And lastly, reuse can be used as a climate mitigation strategy. Over their life cycle, reusables have lower greenhouse gas emissions compared to disposable alternatives. For example, the CO2 impacts of disposable paper, plastic, and bioplastic cups are 3 to 10 times greater than reusable ceramic, stainless steel, and glass. This would directly benefit the communities impacted the most by the effects of climate change, Black and Brown, low-income, and Indigenous communities. Now, we thoroughly discussed the need for consumption-based emissions inventories to be embedded within climate action plans, how climate and reuse are thoroughly connected to one another, and how reuse generates a pathway towards a just transition. The key objective now is knowing how to take this information and inform policymakers and advocates alike on the importance of using reuse solutions as climate mitigation strategies. In order to do this, we encourage you to do the following: to advocate for the use of consumption-based emissions inventories, or CBEIs, to be mandatory when accounting for greenhouse gas emissions, to encourage your local policymakers to update existing climate action plans with source reduction and reuse concepts in mind, to advocate for policymakers to mandate specific source reduction and reuse targets to reduce overall greenhouse gas emissions as low-hanging fruit mitigation strategies, to advocate for source reduction and reuse as one pathway towards a just transition, and to engage directly with climate advocates, businesses, and institutions, and environmental justice stakeholders to underscore the climate and community benefits of switching to reusables. To learn more about how reuse can help solve our climate plastics problem and how to engage with your community and legislators, please check out Upstream's new Climate, Plastics, and Reuse Toolkit. In this toolkit, you'll find the following: a briefing document examining the key connections between reuse and plastics and climate change, 2 fact sheets providing key talking points when engaging with climate stakeholders around reuse as a climate strategy and the impacts of reusables on water and energy usage, a sample letter to a legislator providing a model for how to engage with your representative and encourage them to view reuse solutions as a climate mitigation strategy, and a train the trainer demo presentation, providing a demo of how to give this presentation to key stakeholders. We hope these resources will be very valuable in educating your community and government representatives on how reuse solutions offer one pathway towards a just and regenerative economy. Want to learn more about bringing use to your community? Check out the following resources, including a list of key reports that Upstream has developed, training presentations, as well as our podcasts, our blogs and vlogs, and our live streams brought to you by the Disposable Live. If you are inspired and want to learn more, there are all kinds of ways to do so. At Upstream, we support those who want to start local reuse coalitions, and we host national conversations, including our friends in Canada, with NGOs and businesses in the National Reuse Network, and with government folks in the Government Reuse Forum. I highly encourage you all to sign up for our weekly email newsletter and the Disposable podcast, so you can keep track of the new and exciting ways in which the new reuse economy is unfolding. Thank you so much for tuning in, and please let us know if you have any questions. Looking forward to hearing from you soon. Good luck.